Okay, Assalamu alaikum. So, welcome to week number 12 in module number 4. Today we are going to talk about the direct memory access and its role in a computer system. This direct memory access is part of the computer interface system. Now, assume that we want to transfer information from the outside world. This is our outside world to our hard drive, which is our solid state disk inside our computer. So the conventional way is to take the information. It will go to the CPU. The CPU will issue a move to instruction to the SSD or to the memory, and so on. So if this is going to happen, if we want to transfer a block of information between a fast storage device such as a hard drive and the CPU, this can preoccupy the CPU and permit little, if any, other processes to be accomplished, because this will take all the time needed from the CPU. Instead, removing the CPU from the path, instead sending the information immediately from the outside world to the SSD, can be done through using the memory access device. So removing the CPU from the path and letting the peripheral device manage the memory buses relieves the CPU from many input-output operations and makes the life much easier for the CPU. In this transfer technique, which is called direct memory access, the DMA controller takes over the buses to manage the transfer directly between the input-output devices and the memory. As a consequence, the CPU is temporarily deprived of access to memory and control the memory bus. So the DMA captures the bus in a number of ways. On one common method extensively used in micro-operation is to disable the buses through control signals. So we have the bus request and the bus granted signals, which are responsible for this operation. Now, the bus request and the bus granted will be used to control the devices. As you can see here, this is the CPU and this is the signals. So the DMA will send a bus request to the CPU, and if the CPU is not using the data bus or the address bus, it will send a bus granted back to the original device. So when the bus request in the input is reset and the DMA by the DMA, the CPU returns to its normal operation. When the bus granted line is set, the internal DMA controllers takes control of the system bus in order to communicate directly with the memory. The transfer can be made for an entire block of words, suspending the operation of the CPU until the entire block is transferred, a process referred to as burst transfer or chunk transfer. The CPU merely delays the bus operations for one memory cycle to allow direct memory input-output transfer for one cycle. Now, to accomplish all of this, we need something called the DMA controller. The DMA controller needs usually the circuitry of an interface to communicate with the CPU and the input-output device. In addition, it needs an address register, a word count register, and a set of address lines. The address register and the address lines are used for direct communications with the memory. The word count register specifies the number of words that must be transferred. And finally, the data transfer may be done directly between the device and the memory under the control of the DMA. Figure 9.2, which is this figure, shows us all of this in details. So in this figure, the block diagram of a typical DMA controller, and the unit communicates communicates with the CPU via the data bus and the control bus. The registers in the direct access memory are selected by the CPU through the address bus and by enabling the DMA select and the register select inputs, which are over here. Okay, DS and RS. The read and write inputs are bidirectional. When the bus granted input is 0, the CPU can communicate with the DMA. registers through the data bus to read from or to write to those registers. When the bus granted is 1, the CPU is relinquished of the buses, and the DMA can communicate directly with the memory without the interference of the CPU. The DMA controller has 3 registers, which are the address register, word count register, and control register. The address register contains the address of the specified, or to specify the desired location of a word in the memory. The address bits go through the bus buffers onto the bus address, and the address register is incremented after each word transfer. The word count register holds the number of words to be transferred. This register is decremented after each word is transferred, and it is tested internally until it reaches to 0. The control register specifies the mode of transfer. All registers in the DMA appear to the CPU as input-output interface registers. Thus, the CPU can read from or write to the DMA registers under a program controlled via the data bus. Now, after initialization by the CPU, the DMA starts to and continues to transfer data between memory and the peripheral unit until an entire block is transferred. The initialization process is essential to essentially a program consisting of the input-output instruction that includes the address for the selecting particular DMA register. Now, the CPU initializes the DMA by sending the following information, which is the starting address, the word count address, the control bit, and a control bit for the starting of the DMA transfer. The starting address is stored in the address register. The word count register is stored in the word count. The word count is stored in the word count register, and the control information is in the control register. Once the DMA is initialized, the CPU stops communicating with it unless the CPU receives an interrupt signal from it or from any other peripheral device. The position of the DMA controller is among the other components of a computer system, as shown over here. This is our DMA, this is our peripheral, and this is our memory. So the memory will talk to the DMA, and the DMA will send the information to the memory immediately without going through to the CPU. The CPU communicates with the DMA through the address and the data bus with any interface unit. The DMA has its own address, which activates the data select and register select lines. The CPU initializes the DMA through the data bus. Once the DMA receives the start control bit, it can begin transferring the data between the peripheral devices and the memory. When the peripheral device sends a DMA request, the DMA controller activates the bus request line, informing the CPU that it is to relinquish the buses. The CPU responds with the bus granted line, informing the DMA that the buses are relinquished. The DMA then puts the current value of its address registers onto the address bus, initiating the read and write signals, and sends the DMA acknowledge to the peripheral device. When the peripheral device receives the DMA acknowledge, it puts the words on the data bus for writing or receives a word from the data bus for reading. Thus, the DMA controls the read and write operations and supplies the addresses for the memory. The peripheral unit can then communicate with the memory through the data bus for a direct transfer of data between the two units, while the CPU accesses the data bus momentarily this is disabled. Each word is transferred. The DMA increments the address bus and decrements the word count register. If the word count register reaches to 0, the DMA checks for request line coming from the peripheral. In high-speed devices, the line will be activated as soon as the previous transfer is completed. A second transfer is then initiated. If the speed is slower, the DMA request line may be activated somewhat later. In this case, the DMA resets the bus request line so that the CPU can continue to execute the program. When the peripheral requests a transfer, the DMA requests a bus again. If the word count reaches 0, the DMA stops any transfer and removes its bus requests. It also informs the CPU of any termination of the transfer by means of an interrupt. Now, each channel also has its own address register and the word count register, so that the channels with higher priority devices are served before the channels of the lower priority devices. This is mainly the idea of the DMA. We will discuss it more in details in our class, inshallah.